Hello again, everyone. In this video, I'm going to show you how to create a binary tree in Python. And what you're looking at on the screen is an example of what a binary tree could look like. We're going to use a linked list to create this tree, but you might remember for a doubly linked list, each node had a previous and next field. In a binary tree, we're going to change that to a left and a right field. In any binary tree, the very first node, which in this case is the number 1, is considered the root of the binary tree. All nodes on the left are considered the left subtree of the root. So in this case, the 2, 4, and 5 are the left subtree. All nodes on the right are considered the right subtree of the binary tree. So in this case, the 3, 6, and 7 are the right subtree of the root. Now, of course, we can go down different levels. For this subtree, here on the left, the 2 is the root of the subtree on the left, and the 4 is the left subtree of the subtree, and the 5 is the right subtree of the subtree. Same thing can be said for the nodes on the right. The 3 would be the root of the right subtree. So there are different levels to a subtree, or I'm sorry, to a binary tree. The root is always at level 0. The 2 and the 3 are, that's level 1. Where those last 4 nodes are, that's level 2. And of course, a tree can keep going on and on past that. Now, let's look at some Python code. To make a binary tree, first, once again, you need a class named node. And as you can see, I've made one right here with an initialization function that has one parameter. So within this node, the data field will get the value of the parameter. And once again, here I have a left and a right, a left field and a right field. Both of those are initially set to none. So there's the node class. Then we create a binary tree class. There's not a whole lot of functions in here, but I'll show you what the main one that you need. The initialization function, whenever you create a binary tree class, you're going to create your first node, and that first node is the root. So here in the initialization, we have a root variable, and we're going to say that's equal to node with the parameter data that's passed in. So that becomes the root. So down here in main, this line I've just circled is creating an object of the binary tree class. We're calling it BT. And we assign the value 1. We're passing the value 1 into that. So that means the 1 becomes the root of the binary tree. That's the first node. Now then, what I'm going to do is add the nodes kind of by the brute force method. So here, I'm saying root.left is node parentheses 2, and root.right is node parentheses 3. That creates my level 1, the roots of my subtrees, if you will. Then, here I'm saying root.left.left is 4, and root.left.right is 5. 4 and 5 get created right there. Finally, I have root.right.left is 6. Root.right.right is 7. Those get created right there. And of course, there's my root in blue. All right, now, one more thing to know how to do in the code is how to traverse a binary tree. Traversing a linked list means going through all the nodes in the list. Same thing for a binary tree. To traverse it, you go through all the nodes. However, there's more than one way to do it. I'm going to show you one way. There are 3 ways you can traverse a binary tree. I'm going to show you one way. It's called the pre-order traversal. And as you can see, I've defined a function called pre-order, and I have a parameter passed in called start node, the node where we start traversing. Now, of course, when you call this function, you will send the root node. You always begin at the root. Traversals always begin at the root. But a pre-order traversal works like this. First, you go to the root node, and in our case, we'll print what the data value of that node is. Then you go to the left subtree, and then you go to the right subtree. All right? So let's see what happens. So in our tree down here, I'm going to clear these drawings. In our tree down here, that means to do a pre-order, start with the 1. That's the root. Well, that's the root. That's the first thing. Then you go to the left subtree. Well, that means then you go to the 2. That's the next one. But 2 is the root of this left subtree. So in effect, that's the root. Now you have to go to the left subtree and the right subtree. That means then you do the 4, and then you do the 5. And now you're done with the left subtree. So it's 1, 2, 4, 5. Then, since the left subtree of the root is finished, you come back up here and you go to the right subtree. So then the 3 gets done. And then you have to go to the left node of this subtree. So that's the 6, and then it's the 7. So the order of traversal of nodes should be 1, 2, 4, 5, 3, 6, 7 in a pre-order traversal. Now, here is how we code this. Before I do that, notice right here, I'm calling the pre-order function from main, and the parameter I'm sending is the root. You always send the root when you call these things. So here in the pre-order function, here is an if statement. If start node is not none, and that, since we've already built the tree, that root is definitely not none. It says print start node dot data, and just print that that number. But remember, once you process the root, now you want to process the left subtree. So you've got the root of the whole tree. Then you go to the root of the left subtree. And in pre-order, once you get to the root of the left subtree, then you technically go to the quote-unquote root of the left subtree, and then the root of the right subtree. That was a weird way of saying it, but guess what? This is where recursion is your best friend. Because in effect, once you get the first root, then you want to tackle the left subtree. And after the left subtree is done, you want to tackle the right subtree. But within the left subtree, then you find the root of that subtree, then you tackle the left and the right. So what you're going to do is, once you get the root of the whole thing, which is this print right here, then you're going to recursively call the pre-order function and send it the left node from where you started. And then once that call is finished, you're going to recursively call the pre-order function once more and send it the right node of where you started. Traversing a binary tree is where recursion is your best friend. Don't overthink it. Just get a precursory idea of what you're supposed to do, and just use recursion to express that. Now, for your information, the 2 other ways to do a traversal are post-order traversal, which means the left subtree is first, then the right subtree, and then the root. So I want you in your head to go over this tree that we have right here, this binary tree that you see, and figure out what the order would be in a post-order traversal. And then the third way is an in-order traversal. This does the left subtree first, then it does the root, and then it does the right subtree. So I want you in your head and with a pencil and paper to figure out what the order of these nodes would be that you see here in an in-order traversal. Because I think you're going to have to know how to do all three and how to code all three for homework and a project. Be ready. Let's run this and see what we get. Here's my output. So as you can see, here's my pre-order traversal. Once again, we'll follow the artwork. It's pre-order, so the root is passed in, and it says that the start node is not none, which it isn't. You print the data, so that's the 1. But then you recursively call pre-order, sending the left node. Okay, so in fact, you're sending the 2. That gets printed. But then you call it again. You call pre-order with the left again, and that sends the 4. That prints the 4, but now there's no more left tree, so now you go back to 2, and now do the right one. You call pre-order again with the right node. That prints the 5. And now that whole subtree is done. So you go back to the root, you finish the left subtree of the root, now you go to the right subtree of the root. Well, the first node's a 3, that prints the 3. And now you call pre-order again recursively, and that gets the 6 printed, and then you call pre-order with the right node, and that prints the 7. And that is how you do a pre-order traversal of a binary tree in Python. If you're thinking, you know what? I have a feeling that post-order and in-order traversal is going to look a lot like this pre-order function, just changing the order a little bit. You're right. It will. Trust your instincts on that one. If you have any questions, please send me an email at kmuldrow@lbcc.edu.